Hello all. So I'm going to walk you through my final report. And the goal of this is to look at this data set and define a modeling approach, build a model, and run a modeling evaluation and interpret it. So basically what I'm doing is I'm going to use, looking at the data set I had, I'm going to use the linear regression model to run this, and I'm going to run it with three different models. So what I've done is to divide my data into three parts: 20% for my test data, which I'll use for my final analysis, and 40% of it is going to be used for 20%, another 20% for validation, and then the final 60% for training for the three different models. So what I actually did here was to run a linear regression. After running the linear regression, I got some values which have the coefficients. And so basically what I did was that, so these are my coefficient, my intercept. And so I used that to get a predicted PE for my first model. My first model runs on all the four hyper parameters. That's AT, V, RH, and AAP. So after doing that, I get my data set by multiplying my coefficient and adding my intercept with the various information I have here, and gives me my predicted PE, and then I compare my correlation values with my R square, and I'm very sure that it closely aligns. And I repeat the same this time around using only AT and V. I do the same. I run my training data, and then I also do my validation, get my predicted PE, get my correlation and my R squared, and you see it's very close. I also do the same thing for the final one, and then I get the same results. So I'm running the same training data and validation information, and I get all this predicted P. Then finally, I do my comparison. So I had four hyperparameters in the first one, three, and then I have two here. So what I did here was I looked at, I rounded up to four decimal places, and I looked like, okay, this one is a bit far from one, means that it's not giving me a very exact strong match, and also looking at the error, it's a bit on the high side uh, compared to the other two. So I selected model 3, and the reason why I selected model 3 is because it looks is closely related to model 1, close to 1. Looking at the R squared is also very close, and also uses fewer hyperparameters, so I think it's simpler to use. So what I did in the final one is to train my model, do a final training using both training and validation data. So I train using both validation data. I get some outputs, and which I'm going to use to run um, on my test data. So basically, I run it on my test data. I get this outputs, and then I see this. I'm able to compare my predicted P and my this so and my actual P. So I get the final correlation and also my R squared, and then I compare it. I see that this is very close to my what I have in my data set, even giving me a little bit more of accuracy comparing these two. So the reason for going along this line is to ensure that if you look at the first this model, it indicates a very strong correlation between the predicted and the actual P. And then also the model gives me a good explanation of a 92.7% variance in power output, which I think is an excellent predictive accuracy. And so yeah, so if I'm going to interpret what I finally did and say, um, my model, selecting this model, it demonstrates a high predictive power with minimal complexity compared to using all four variables, and also dropping the AP did not significantly reduce accuracy, making the model more efficient and easier to interpret. Residual errors are low, as reflected by R squared, and low standard error, meaning predictions closely match actual values. So basically, choosing this lies on three things: accuracy, efficiency, and ease of interpretation. And also, implementing it to give a strong performance. Now, the only limitations I see about this is that excluding AP may slightly reduce accuracy in scenarios where pressure signal influences power output, and also model assumes linear relationships. Um, Non-linear effects are not captured in this one. So thank you all for listening to this.